Okay, we've got a lovely trig thing to solve. We're solving an equation, we've got an interval to solve it on. Now it's got a sine of 2 theta and also a sine of theta. These don't match. So therefore I'm going to have to deal with the sine of 2 theta. Okay, so what can I do with sine of 2 theta? Well, I have learned, now we don't have these in the formula book, but there is a formula you learn that says that sine of 2 theta is 2 sine theta cos theta. So I had a 2 anyway. I've now got a 2 from the formula, and that has got to equal sine of theta. So I am solving for sine theta cos theta equals sine of theta. Now what is very tempting to do is to think you can divide by sine of theta, but if you do, you're going to lose some solutions. It's like having 4x squared equals x, which is a quadratic equation with two solutions. If you divide by the x to get 4x equals 1, you'll lose the other solution. What you're supposed to do with 4x equaling x is get 4x squared minus x equals 0, okay, then take out a common factor of x and get this, and then you see that you've got the two possibilities, x equals 0 or the 4x minus 1 equals 0. So that's what we're going to do over here. We're not going to divide by the sine theta. We're going to do 4 sine theta cos theta. We're going to take away the sine theta. We're going to get 0. We're going to factorize. The common factor is sine theta. So we're going to get 4 cos of theta minus 1 equaling 0. And again, we've got the possibilities. Okay, so things that are factorized equaling 0, it doesn't have to be a quadratic equation. Really powerful idea. Either the first thing equals 0, so in this case sine theta equals 0, or 4 cos theta minus 1 equals 0. So just as an aside, if you're ever given anything in the form of a factor times another factor equals 0, what you don't do is multiply it out. Okay, as soon as you've got something times something else is 0, either the first one's 0 or the second one's 0, and that's you know, big style useful. Okay, so sine theta equaling 0. You're not going to use your calculator for that because you know the sine graph for 0 to 360 degrees does that. This is 0, this is 180 degrees, this is 360 degrees. Okay, we're in degrees again for some reason. I expect to be in radians, but we're in degrees. Okay, so I'm going to get 0 degrees, 180 degrees, and 360 degrees from that one, just from the graph. This one here gives me cos of theta. Well, 4 cos theta is a quarter, so cos of theta equals, no, 4 cos theta is 1. Equals 1. So cos theta is a quarter. So my first solution, my first theta is inverse cos of a quarter, which my calculator is going to tell me, put it in degree mode. Okay, inverse cos of 0.5 equals 75.5 degrees. But of course, the second solution, use your favourite method for getting your second solution for theta, and you realise you need to do 360 degrees minus the 75.5 degrees. That's what the graph shows you need to do, and that's going to be 284.5. So those are my 5 solutions. So I've just got to summarise theta equals 0, 180, these are in degrees, 360 degrees, or 75.5 degrees, or 284.5 degrees. Isn't that fun?